This video is going to cover section 7.5 in your book. We have 4 objectives. The first is to solve a formula for a given variable. The second is to understand direct variation. The third is to understand indirect variation. And the fourth is to understand joint and combined variation. So let's look at our vocabulary. Again, put this in your vocabulary list or on your vocabulary note cards. And go through those on a regular basis and quiz yourself to make sure that you're remembering all the terms that we're using. First vocabulary term is direct variation. So direct variation is a linear function of the form f of x equals kx, where k is a non-zero constant. In other words, as x changes by a factor of k, so does the value of f of x. It's a direct relationship in their variation. And k, that non-zero constant, we refer to that as the variation constant. So remember, a constant is a number. It is not a variable. And with variation, you can't have it be 0. Oh, I see a mistake here. I'm going to fix real quickly. That should be equals. Indirect variation is very similar, except now our linear function is k over x. X is now in the denominator. That means as one goes up, the other goes down. They vary indirectly, in opposite directions. And joint variation, you can just add more variables. So y can vary jointly as x and z. Okay, you can just put them together, and it's the product that it varies with. Okay, solving formulas for a variable. Going to do a couple examples of this. Make sure you remember it. You will have done this before. We're solving this formula, S equals the quantity V1 plus V2 times T over 2. We're solving it for T. So that's the one that we want to get all alone, all by itself. First thing I want to do is clear the denominator. So I'm going to multiply both sides by 2, and I will get 2S equals V1 plus V2 times T. And again, it's T that I want all by itself, so I'm going to divide both sides by this quantity V1 plus V2. And here they'll cancel out. And I'll get T equals 2S over V1 plus V2. And that's the answer. I've solved it for V. When it says for T. When it says to solve a formula for a specific variable, that means you isolate that specific variable on one side of the equal sign. Your book gives you a set of steps or rules to follow for it, but I don't find it the most helpful because each problem is just a little bit slightly different. And you really want to just think through, how do you solve for a particular variable? What are the steps you go through in equation solving to get something all by itself? We'll do one more example of this. This time we want to solve for capital R, which is 2 different places. So the first thing I'm going to do is I'm going to cross multiply. We have one rational expression equal to another rational expression. Anytime you have that, you can cross multiply. So we get ER equals, and when I multiply the small e times the big R plus little r, I'm going to distribute. So I'll call that ER plus ER. Now I want to get everything with the capital R in it over to one side, because that's part of isolating a variable by itself on one side, is starting by getting every term with that variable on that side. So we'll have ER minus little er equals little e. All right, that's a capital R. You have to be very careful with these to keep your capitals straight. Now here I have big R in both this term and this term, so I'm going to factor that capital R out. And that'll leave me with big E minus little e, and that equals little e, little r. And now I just have to divide by this expression that is multiplied by my variable of interest. And I will get R equals little e, little r over big E minus little e. Again, just remember all the steps that you go through when you're solving equations. It's not the end of the world if you make a mistake in terms of, that didn't help you get anywhere, because you can always just keep moving forward and eventually get somewhere. So that covers our first objective, solving equations for specific variables. Now we're going to do some variation. I'm just going to do by example. Okay? And I'll walk you through the examples as I do it. So when it says that y varies directly as the square of x, what that means is that y equals k, our constant of variability, or our variability constant, times x squared. Okay, so we want to start by writing that formula for direct variation, and now we're going to solve for k, because that's a number we really need to know. Well, when y equals 6 and x equals 3, so x squared equals 9, we'll get 6 over 9, or 2/3 for k. And then what we do is we take this 2/3 for k and we put it back into the original equation. So it looks like this. Y equals 2/3 x squared. And that's your answer. So what you're doing is you're setting up a generic direct variation equation, solving for that constant k, and then putting that constant k back into your original equation. And this one will be inversely. Okay, so now we have y varies inversely as the square of x. So now it's k over x squared. And we want to do the same thing, solve for k. When y is 6, x is 3, so 3 squared is 9, and we'll multiply both sides by 9. And we'll get k equals, what is that, 54. So now we're going to take that k, and we're going to put it back right in here. So we will get y equals 54 over x squared. Y varies directly as x and inversely as w and the square of z. Okay, so the hardest thing with this is setting up our initial equation. So it'll be y varies, okay, k is always going to go in the numerator, and so's whatever it varies directly with, x. The denominator is going to take whatever it varies inversely with, w z squared. And now we want to solve for k, so that we can put it back in to this equation and have our equation of variation. So we have all these values. Y equals 4.5 equals k times 15, or 15k, over 5 times 2 squared is 4, so 4. In other words, 4.5 equals 15 over 20 is 3 over 4, or 0.75, because I'm going to try to get it all into decimals now, k. And if we divide both sides by 0.75, we will get k equals 6. So again, now we take this value for k and we put it back into our original. We're going to end up with an answer of y equals 6x over wz squared. So remember, if it varies directly with a variable, that variable is going to go in the numerator. If y varies indirectly with a variable, that variable will go in the denominator. And k, the variation constant, is always in the numerator, and we solve for that.